today, besides all this amazing innovation, it seems like we're hitting a wall. And if you look on the last few weeks, the amount of pressure around the cost, about the power consumption that many companies, you probably heard about Microsoft and Google chasing nuclear power plants, and how do we feed all the power to those huge supercomputers? Today I want to talk to you about the other side of taking those trained models that are using those supercomputers, and how can we deploy them in a more affordable way, so we can really deploy them in every line of business, even in smart cities that they don't have the amount of budget that Meta or Google or Microsoft have. But I'll start with a bet. If I would ask you which of these cars will get it to the mountain, the first mountain stop first, who would you bet on? I guess you want to know what's the size of the engine, who's driving, what's the traction system, etc. Now, if I would ask you who would come first, would you care about the size of the engine? Well, actually, when we're looking on what's going on in data centers today, and the amazing H100, B100 from NVIDIA, the MI300 GPU from AMD, and the other TPU V5, V6 that are coming, it's kind of the same problem. We're making the AI processor, the AI accelerator, stronger and bigger, but no one is adopting the interconnect to it, the system around it, and making sure that we can deploy models in a more efficient way. So we're actually ending up wasting a lot of the cost and the power that we invested. And you know, with every technology, the success of a technology is when it becomes ubiquitous. And ubiquity usually comes when you can afford it, when many market segments can afford that. And when you look on how we can get to the point where the cost of million tokens drops from 25 cents to less than a cent, you need to consider the cost of the infrastructure, the cost of the software layers above it, user experience, that is many times pulling a lot of investment that 7-Eleven R&D center doesn't have. You have the real estate issue. You know, the new Blackwell rack that Jensen announced about 4 months ago consumed 140 kilowatt. When you look into some of the biggest data centers that Bank of America have, or JP Morgan or other companies, they have power supply of 13 kilowatt, or 15 or 18 to each rack. You cannot buy this and install it. So we need to consider all this when we're suggesting how to solve the problem. The first thing to look at is the difference between training, the process of teaching a neural network or a set of neural networks in a pipeline to classify an image, to do a multimodality embedding and understanding. And it's usually a long process, and the spending is the R&D spending. This is not something that is directly attached to the cost of our product. When you look on inference, this is something you do on a daily basis. You want to update it on a daily basis, you want to deploy fast, you want the cost to be very low, and the attention and the innovation that you drive into training is what's leading everything. With inference, it's how fast I can deploy and how much value, how much ROI can I get on it. These different drivers go to the purpose, of course. The purpose of training is to drive innovation. The purpose of inference is to run data center operation to support my business in terms of budget, R&D spending versus my cost of sale. In terms of computation, I want to train my models the fastest I can. So I'll use the biggest supercomputer that will finish this job fast and have my PhDs go to the next iteration of improvement. With inference, I want to use the lowest cost infrastructure that I can, embedded if possible, or data center if possible. The precision is different. With training, we're using high precision, 64-bit, floating point, 32. with the inference, we sometimes drop to integer 8, integer 4. We already have some deployed inference running in 1 bit of precision. And it goes on and on and on. And when you define where you want to take your infrastructure, you need to understand the differences between training and between inference so you can adapt your infrastructure for inference.